Next up, I would like the bond order of B2 minus and to find out whether it's paramagnetic or diamagnetic. So first, let's figure out what the bond order is. So the bond order is going to be equal to the number of bonding electrons minus the number of anti-bonding electrons, and then it's going to all be over 2. I find these values by looking at the MO diagram of B2 minus. Next up, we need to figure out what paramagnetic or diamagnetic means so that we can know what we're looking for based off of this bond order and based off of the MO diagram. Paramagnetic means that it will interact with a magnetic field. Diamagnetic will of course be the opposite, and that means it will not interact with a magnetic field. How I determine whether it's which one it is I'll look at the total spin, and depending on whether that spin is non-zero or whether it is so whether it's non-zero, whether it's equal to 0, will tell me which one of these two it is, and that's because the spin will generate an intrinsic angular momentum. So the spin is the intrinsic angular momentum, and that angular momentum will generate a magnetic field. And so that is why it will interact, a magnetic moment that will interact with this magnetic field. And so let's go about drawing the orbital diagram for B2 minus. And so I'm going to have energy increasing that way. I'm going to have B and B minus. Let's fill in the atomic orbitals. And B minus will have an additional one. Okay, let's go about filling in the molecular orbitals. And then filling in the electrons. Okay, and then now we can go about calculating the bond order. So it is going to be, let's label these. So this is going to be a bonding sigma. This is going to be an anti-bonding sigma, 1s, 1s. Again, a bonding sigma, 2s, anti-bonding sigma, 2s. And then this one is going to be, again, a sigma 2p bonding and a bonding pi 2p. And so if I count the electrons in bonding, I have 2 here, plus 2 here, plus the, 2 here, plus the 2 here, plus the 2 here, plus the 1. And so that's going to give me 2, 4, 6, 7. So I have 7 in bonding. Anti-bonding, I have 2, 4. That's it. And then that's going to be over 2. And that is going to give me 3 over 2. So the bonding order is going to be 3 over 2, and that's 1.5. Now I need to determine whether it is going to be paramagnetic or diamagnetic. So for the spins, the spin up and spin down are going to cancel because that's plus 1 over 2 plus minus 1 over 2, and that is going to give me a 0. And so here the spin will be 0, spin 0, spin 0, spin 0, spin 0, but here I just have the plus 1 over 2. So the spin is going to be 0 plus 0 plus 1, 2, 3, 4, 5, so 5 zeros, plus the 1 over 2, which is clearly non-zero. That means that spin that's left over up there is going to generate an intrinsic angular momentum, and that's going to generate a magnetic moment that will indeed interact with a magnetic field. And so that is going to mean that it is going to be paramagnetic. And that's it for this question.